Welcome back to The Explainer. Today, we are unpacking something absolutely massive. We are looking closely at the highly anticipated launch of India's revolutionary new green train, the Namo Green Rail. We're going to dig right into the facts, the cutting-edge science, and the heavy-duty infrastructure making this all possible, drawn straight from the latest reports. So get ready. Okay, let's dive into this. Today's roadmap is going to guide us through 5 key areas: the Green Rail revolution, a look inside the Namo Green Rail, how hydrogen powers trains, fueling and safety first, and finally, India's net zero future. Section 1, the Green Rail revolution. Indian Railways is beginning an entirely new chapter here. I want you to just imagine this for a second. What if a massive, heavy-duty train's only exhaust was water? No thick diesel smoke, no heavy carbon emissions pumping into the atmosphere, just pure, clean water vapor. Well, that surprising concept is exactly what's happening, and replacing diesel smoke with water vapor is the driving force behind this entire explainer. Based on the sources, India's very first hydrogen-powered train is officially getting the green light. Prime Minister Narendra Modi is expected to flag off this historic zero-emission train on July 17th in Haryana. It is a true breaking news moment where traditional heavy transport literally meets futuristic clean energy. Let's move to and see how this builds on what came before. If you look at the historical timeline of Indian transit, it's constantly evolving, right? We started way back in the steam era, moved into the heavy fossil fuels of the diesel era, and then transitioned to the electric era powered by overhead wires. And now, we are officially entering the hydrogen era. The incredible shift here is that we're moving to a train that actually generates its own clean electricity as it moves. It's a real game changer. Section 2, inside the Namo Green Rail. Let's zoom in on the physical train itself. The numbers here are just super impressive. The train features 10 coaches with a huge capacity capable of moving over 2,600 passengers at a time. It's set to run on the 89-kilometer Jind-Sonipat route, making 2 round trips daily to cover about 356 kilometers. And during trial runs, it hits speeds between 85 and 110 kilometers per hour. But here is the real standout stat. The propulsion system generates 1,200 kilowatts. To put that into perspective, that's roughly 1,600 horsepower, making this specific model one of the most powerful hydrogen passenger trains developed globally so far. What's also crucial to note is that the Namo Green Rail is a fully indigenous prototype from idea to execution. It is 100% made in India. We're talking from the initial concept designed at the Research Designs and Standards Organization in Lucknow all the way to the actual manufacturing at the Integral Coach Factory in Chennai. This is a massive step forward for India's domestic manufacturing capabilities. Section 3, how hydrogen powers trains. Let's look at the actual chemical engineering making this happen. So, how does it actually work? Well, instead of burning fossil fuels, the train uses highly compressed hydrogen gas. Inside 3 dedicated power coaches, there's a brilliant little device called a fuel cell. This fuel cell forces the hydrogen gas to react with oxygen. That chemical reaction directly generates clean electricity, which then powers the motors. And the best part, the only byproduct released into the air is pure water. It's practically a mini water cycle on wheels. Now, what's really interesting about this slide is the contrast. Traditional diesel relies on fossil fuels and pumps out carbon. Hydrogen uses renewable energy and emits water. But you might be wondering, why not just use standard electric trains? Well, while India has heavily electrified its railways, overhead electric wires simply aren't practical or even possible on every single route. Hydrogen is the perfect solution for those gaps because the train literally brings its own self-generating power plant right on board. And the efficiency doesn't stop there. The train features an incredibly clever system known as regenerative braking. Normally, when a train hits the brakes, all that kinetic energy is just lost as friction and heat. But here, that energy is captured and stored right back into the train's onboard battery systems. Literally, zero energy is wasted. It constantly recycles power on the move to maximize the range, which has already been tested up to 250 kilometers on a single fueling. Section 4, fueling and safety first. Let's address the natural skepticism you might have about using combustible hydrogen gas. To keep a machine like this running, you need some serious back-end infrastructure. Indian Railways actually set up a dedicated indigenous hydrogen storage and refueling facility in Jind. This plant literally breaks down water, using water electrolysis to harvest the hydrogen fuel. It boasts a 3,000 kilogram storage capacity. The train itself carries about 440 kilograms of compressed hydrogen in specialized cylinders at the front and back, and it'll consume around 300 kilograms a day during full commercial operation. Because hydrogen requires careful handling, the train was built from the ground up with a rigorous safety-first approach. They've got highly sensitive hydrogen leak detectors, rapid response flame sensors, robust pressure control systems, and advanced ventilation mechanisms to prevent any gas buildup. Plus, there is 24/7 camera monitoring inside the coaches to ensure passenger safety and provide emergency response options at all times. And for ultimate reassurance, the entire operation has been certified by TUVSUD, which is an international testing and certification organization. This shows that the safety metrics meet strict, globally recognized standards. Basically, they aren't taking any chances here. Section 5. India's Net Zero Future. Let's zoom all the way out and look at the big picture. So, the crucial point is the commitment level. Indian Railways has allocated a massive budget of 2,800 crore rupees for this initiative. They're not stopping at just one prototype. The long-term plan is to deploy 35 hydrogen trains under an initiative called Hydrogen for Heritage. These trains are going to run on heritage and tourism routes across the country, perfectly combining sustainability with the tourism sector. This launch also elevates India into a highly exclusive group of nations. We're talking about the Global Clean Mobility Club, joining Germany, Japan, China, and the United States, who are actively pioneering hydrogen rail transport. It's a remarkable leap that puts India right at the forefront of global transit technology. So why does all of this matter to us? Because projects like the Namo Green Rail are directly linked to India's highly ambitious Net Zero 2070 goals. By replacing diesel, the country cuts down heavily on fossil fuel imports, which seriously boosts national energy security. But beyond that, it's creating an entirely new green economy. From manufacturing and storage to transport and maintenance, this hydrogen sector is going to be packed with real opportunities and new jobs for the next generation. Which brings us to our final thought today. Looking at everything we've unpacked from the sources, ask yourself, is this just a transport upgrade or the dawn of a completely new green economy for India? It definitely feels like the wheels of a much larger transformation are in motion. A huge thank you for joining me for this explainer today. Keep tracking the future of renewable tech because progress is moving incredibly fast and it's leaving behind nothing but water. See you next time.